This is the welcome message for Advanced Data Analytics 2018. I'm Jun Lee, the lecturer and coordinator of this subject. Very welcome. So, in this message, we'll discuss what the subject is, what it's about, what to be expected during the class and in the lab tutorials, and how to prepare your study. And very importantly, the assignments. From past years' experience, I know that I would have very little attention from you in this message, so let's jump first to the assignments. The structure of the assignment is designed as follows. First, we will give you some papers to read about in the topic, in the general topic of machine learning, data analytics, artificial intelligence, data mining. Okay, in the very beginning of the semester, the first week, you will choose from a list of papers one that you have most interest in. And after choosing this paper, you read it. You have 4 weeks to read. Look, the due date for this assignment is week 5, so you have 4 weeks to read it and write a critical report about that. The requirement is the same for both the undergraduate and the postgraduate student. And getting some knowledge about the area, and hopefully you will find your initial interest persists at that stage. You can choose to implement the technique you have learned from the first assignment, or when you have studied the literature, you may find some other interesting things. Whatever. Um, the task for assignment 2 is to implement something, either a practical data analytics algorithm, or you do not implement the algorithm but apply some state-of-the-art algorithm and apply it to some practical tasks, and also write a report about it. For undergraduate students, this task weight 40% of your total marks, and for postgraduate student that weight 30% of the marks. For the undergraduate students, please notice that you would need to present your project and record it into a movie, upload it to like some place like YouTube, and submit the movie along with your report and also with your project. For assignment 3 for undergraduates and postgraduate students are different. For undergraduate students, you would be given a list of open problems in the area in week 10, and you choose one of them that is mostly interested to you or you have most confidence in. To study in the literature, apply the skills you have acquired in the study and in doing assignment 1 and 2. Form a report in 1 week and submit your report in week 11. For postgraduate students, the task is similar to that of assignment 2, only that in this task, when you do the report about some data analytic projects, you do not need to implement the project. It is a proposal. The task is mainly on justifying and planning data analytic research. You will need to make a pitch video about your proposal and upload the pitch video as undergraduate student did in assignment 2. And that task weights 30% for undergraduate students and 40% for postgraduate students. Notice that the due date the due date of assignment 3 is only 1 week after that of the assignment 2. But don't be panic. First, for the postgraduate students, um, it is well agreeable to do assignment 2 and 3 altogether while you form some idea and implement what you can implement in the assignment 2. And you have some ideas about future research. Then you summarize these ideas and do some formalization, do some polish, and make proposal for assignment 3. For undergraduate students, you also didn't need to neither you need to implement anything for assignment 3. You do a study. The important thing is to make your study report logical and self-consistent. Or consider it this way: we have converted a closed exam into an open and take-home exam, and the time is 1 week. So how to prepare the study of this subject? I also summarized some materials and some generic guidelines for the subject at the end of this welcome message, but I know this stuff won't get much attention. So yes, get back to the preparation which is necessary for the subject and before each week's lecture. This mind map summarizes or sketches some necessary background theory as well as uh, skills before we get in the area of artificial intelligence or data analytics. Yes, we need math and a lot of it. But before you get panicked, fortunately, we need math at the engineers level, not mathematicians level. We need a lot of notions from math and draw inspiration from the math study. But we do not need a lot of math formalities, proof, rigorous stuff like that. The concepts listed here are not complete, but just from my experience, they are very frequently encountered. You do not need the formal definition, and of course, you do not need to memorize anything of them, but you'd better to get familiarized with those terms in case you are scared off from your study, and just some intuition about them are sufficient. For example, I put algebra and geometry here. You might find such combination is weird in terms of summarize things. However, in our business, considering the data are numbers, and in reality, a lot of objects are described by a set of attributes which are numbers. If you put those numbers together, you would have some math object called a vector, and we can consider the space those vector guys live, and all those vectors are gathered together into population. The population spread in the space, so you arrive the idea both algebra and about the numbers and the geometry, about the shapes and distribution. The knowledge about probabilistic and statistics helps us to build models explaining things that are observed to happen or the data we collect, and which is also useful for future predictions. And associated concepts include the means, variance of distributions, etc. And tools. We need programming in this subject, and the tool I choose is Python. So before we get into the programming, let's see some necessary preparation of your computer environment. Yes, to get the most out of this subject, you would need to prepare your own personal computer. Uh, One reason is that we sometimes need the state-of-the-art software tools which cannot be prepared in time by the IT support. And more importantly, we often use large datasets which may not fit into your home directory. The first piece of very useful tool is terminal, which comes by default with every system. I'm using a Mac computer, and to find a terminal, you can get your Spotlight search and enter terminal. So it will give you a window of command line interface, and it is important, useful, but surprisingly not everybody knows a concept of home directory. Look this tutorial here, that means now you are in a command line and the working directory is at your home. To have a look at where are you, you can type like pwd print work directory. That is me, and keep in mind the working directory, which is a very useful concept when you're experimenting with the data, the program, etc. And well, although for most or arguably all of the functions I will introduce in the follows and in the semester, you can find the GUI graphics interface tools for all the functions, but try to be familiar with the command line tool of your system. It would bring you incredible enhance of in terms of efficiency. Like the material of this course, I will use the next tool, that is Git, and I will use that tool using my terminal. If you do not have Git, don't be panic. I will introduce in the next tool on how to get it. If you have Git, you can type Git. The command line, you have a list of commands, and with a brief introduction on how to use them and the function. Let me get into a temp directory, which I have here, and the materials of this course, I will maintain all of them in a Git repository, that is Git clone. Oh no, not this one. That github.com, my username, and Advanced Data Analytics 2018 student.git. Sure. So after that, you would have a directory called ADA 2018. You can have a look at it, list the directory, and you have necessary files. We will talk those later. And at this point, you can open the current directory in a Finder, or in a Windows computer, you can use Explorer to have a look at this directory and the files, which is also convenient. Okay. So yes, in the next useful tool is of course package manager. In case you do not have a Git right now, you may want to use install.it. If you are using a Windows computer, that generally won't be a problem. But if you use a Linux or okay, if you use a Linux computer, probably you know how to deal with this matter. But if you use Mac computer, I would strongly recommend a semi-official package manager. It's called Homebrew. Well, I will add a link to this item, so when you visit our sketchboard later, you would be able to click here and have a look at how to install Homebrew and how to use Homebrew. Using Homebrew, you can install all the other tools or all the other native tools. And for the development, we will use the Python language, which I will introduce very soon. And we will use the integrated version distribution of Python. It's called Anaconda. And Anaconda itself comes with a Python package manager tool. That means it can help you to install software packages mainly for your development. It's called Conda. If for some reason some package isn't in the Conda repository, you can use the standard Python management tool called pip. I will add links to all those tools, so you would be able to click those terms later when you visit this web page and have a look at the documentation of those. And when you have set up everything and start developing, it is useful to have not only for this subject but also for in general terms of development. It is very useful to have a tool that allows you edit, browse, navigate in your code base easily and provide you an efficient debugger. For Python, a very good tool is PyCharm, and I noticed that recently Microsoft has made their VS Code very popular and useful as well. I use PyCharm, and but this doesn't matter. This is a very personal choice. As long as you find your tool is convenient and efficient to use, it's okay. The important thing is make yourself comfortable and efficient. And also you will need, if you are inexperienced, very important choice is your editor. Do not use the default editor come with the system, such as the Notepad or text editor. Try use someone that helps you to write your code efficiently, such as Vim, which I use. And I like it. Why I like it? Because the design of it is elegant and it's also adopted by a lot of other tools. So although Vim has a very deep learning curve, but as long as you master it, it will pay off you later. And any other reasonable ones should be okay. For the Python language, as I said before, we will use Anaconda. I will visit the Conda website right now. Following the URL, you can find the download and documentation of Anaconda. Anaconda, as I said above, is an integrated environment of Python language. It provides you the Python interpreter and comes with default, by default, a bunch of useful tools for especially for scientific computation, in particular the NAPI, which we will use later, and Panda and data visualization tools, etc., etc. Most importantly, Anaconda comes with its own package manager, which named Conda, we said above. That package manager brings you the package that you can install within your installation of Anaconda. It would have no interface with your system default packages, so much less conflict, risk of conflicts. And also, the packages are have already been set up to be compatible with other computation packages in the Conda, so it's generally very easy to set up compared to if you use the native packages or you need to compile something from source code. Another very important issue we need to mention here is from this year, we will adopt Python version 3 for this subject. I don't think I will have enough time to remake all the video lectures we accumulated through 2016 and 2017. Those older video lectures are using Python 2. In terms of studying data analytic algorithms, the difference between Python 3 and Python 2 is minimal. Mostly, there are minor differences in the printing, the grammar for printing stuff. That is the print. In Python 2, print you use as a command. In Python 3, it is as a function. And there are some other minor differences. You might want to check on the internet those differences when you try to follow previous video lectures. And I also will provide the older version of the notebooks for a reference. But definitely, I will test everything in Python 3 for this year's new version of notebooks and codes. And for the Python packages we will use, there are some important ones. One is NumPy, which is the most important one, and it can help us to deal with numerical computations, especially computation with matrices, arrays, and big data such as a large vector. This helps you manage a lot of parallelization, memory management, stuff like that. And scikit-learn is a package that includes a lot of existing machine learning, data mining algorithms, and also comes with nice data visualization tools. However, as far as I'm concerned, I think scikit-learn's implementation is mostly for study. They are not efficient enough for deployment from my point of view. But that very much depends on the application. If the application involves very complex, elegant algorithm that has already been implemented in scikit-learn, so in terms of prototype timing, a time cost, maybe that is a very good choice. And the third tool I want to introduce in the course, if I have time, is PyTorch. Now it is pretty much thought of deep neural network computation framework, which is called deep learning. And a comparison to a tool that is similar to PyTorch is TensorFlow. Both are frameworks that allows you to freely ship your computation from CPU to graphical processing units and can enhance the computation speed by several tens of times. So these are the useful tools, and for the other tools, I will introduce them when we encounter those. Also, lastly, but very importantly, is a front end called Jupyter Notebook. It's a very nice interface for you to experiment with your code and also take some notes, organizing all the stuff for your study for a project. In this course, I will organize most of the learning material in different notebooks. We will see one very shortly. In the next, I will show some examples, but before the examples, I would like to talk a topic which I think may be the most important stuff you could learn from the course, which is where to seek help, and especially where to seek help when things go wrong. First, I confidently assume that you all know how to get up-to-date information about this area on Google, places such as Reddit groups, Korea, watching YouTube videos, and following some interesting bloggers that is very active in this area. Now let's say that you have learned something that is interesting, and what next? First place you want to have a look might be GitHub. Um, Normally, when you heard of some cool idea or interesting thing or something useful to your project, you might want to have a look, first-hand look of the thing to try it yourself. And the good thing nowadays is people normally will publish code along with their research job works. So for example, like if you are in the automobile industry and are interested in some state-of-the-art safety measures about automatically detect pedestrians to prevent collision or autonomous driving cars, and want to search something about pedestrian detection from cameras, we use the search keyword of detection of pedestrian and put it GitHub. Maybe also I want to check for my convenience. I use the tool called PyTorch, or if you use TensorFlow, you can put TensorFlow here. Let's look. Oh yeah, look. Here is an project which you can use for detect pedestrians. There, have a look at the README setup, every stuff, and the performance evaluation. Well, also some open issues. Then you are free to clone or copy this project and have a try. Okay, and another very important scenario might be that, well, you get into some trouble. This is a special scenario where a skillful Googling can save you hours. Let us see an example which is often encountered by beginners. This is a piece of code when I'm updating the notebook we will use, and to make sure everything goes smoothly for this semester, let's run it. Well, okay, this message is explicit enough for people who are familiar with Python. But let's say you are a beginner and do not know how to do about it. I would suggest the first reaction is to copy the error message, the most relevant error message, to Google and have a look. Okay, look, the first result of the search is very relevant. You can read it, and it would, of course, solve your problem. In case you do not know why this is missing parenthesis, okay, this is how to solve the missing parenthesis by providing it a pair of parentheses. As to the question, which error message is the most relevant one? In Python, the rule of thumb is that the one that has been printed lastly is probably the most relevant one. There are different cases, and with you accumulating more experience, you will get the point. And sometimes we have to admit the situation is so complicated. You find you are um, stuck even in explicitly formulate the questions or get something to search for. In this case, my experience is to, well, press yourself and try to formulate a legitimate question on Stack Overflow. You will find that they have a very specific checklist for you to follow before you can ask a question. And often, in the way of formulating the question, you will find your problem solved. And otherwise, you have made an activate contribute to the community, right? Okay. What and how to learn the subject? The science of data analytics, machine learning, artificial intelligence are all heavily motivated and inspired by mathematical analysis of practical problems. So it is important to learn both theory and hands-on experience in this area. I will try to introduce most of the theory in the classes and also give everybody chances to experiment the theory on toy problems. In lab tutorials, we will guide students with practical data analytic experiments. So there are 6 basic lectures in this subject. In the first, I will review um, some concepts and techniques we have already learned in the introductory data analytics, the prerequisites of this subject. And we introduced the very basic model, which is linear model. The model, how fit the model to the data, that is the training algorithm, and how to implement such a model on practical data. And the second lecture, we will develop from the linear models and introduce the very hot topic of neural networks recently. And after getting some idea about practical models, we consider the the principle behind many data analytic techniques, that is information theory. We will revisit the decision tree models we have learned previously and discuss how to measure information in the third lecture. In the fourth lecture, we will consider how to combine different models together to form a stronger model to deal with some problems that might not be very convenient for you to formulate into one model, that is resampling and bagging methods. In the fifth lecture, we consider data representation and unsupervised learning. That means learning without the part of information which is only available to you in building the model. That means when building the model, we frame the problem as if we have already deployed the, the model we have built. And to be honest, I do not have a very sure idea about the sixth lecture. Previously, we do Bayesian school of thinking the problem. That means to frame the entire analytics into probabilistic framework. But it turns out one of the guest lecture in previous years did this subject much better than myself. And I also want to introduce some concepts about the recent very trendy topic called reinforcement learning. So let's see